In previous videos, we've created the tree, we've been able to traverse trees, but what about if we want to print a tree? So if we're given a basic tree like this, we're going to want to print it like the following here. We have our 1, and then we'll print 2, we'll print 3, and then we'll print 4, we'll print 5, we'll print 6, and we'll print 7. That way, if you were able to rotate this 90 degrees, you would have it in order, kind of like a pyramid. But this is how we're going to focus it for this video. So to do something like this, you can see that we are going to have to deal with a certain amount of spacing. We could say that this has no spacing in front of it, this 1. The second level, because remember these are all levels, this is level 2, this is level 1, or actually this is level 0, this is level 1, sorry, and this is level 2. So this one has 1 space, and then this one we could say has 2 spaces. So the spacing is based off the level. Let's keep that in mind. And you can change how this prints, either like how I have it written here, or how I'll do it for this video where I'll print 1, and then we'll do the 3 on top, and we'll do 7, 6, and then we'll have our 2, and then our 4, 5 like this. If you wanted to do it the other way, which is the way I wrote out initially, that's totally fine. It's just going to be the reverse kind of what I'm going to code out in this video. So yes, we are coding. We're going to be adding to our class that we have created. So it's going to look something like this output. Now you can see that the root is going to be in the middle of our print. So it's kind of a fork, if you will, of our print in order. We're going to modify this just a little bit. So with that also in mind, let's go down here and start coding. First, we are going to want to have a public method that we can access this with. We're going to have public void because it's just printing. Remember, we're printing here. And we want to print it sideways. So we'll do print sideways. And then we're going to have no parameters. And what we're going to want to do in here is call our recursive method. So we'll call print sideways, but remember we're going to pass in a argument here, that way we can make this private. What we're going to want to pass in is first the overall root. Remember, we've made a class in tree, we have this overall root here. These two methods are constructors, they're used with each other, and they're essentially going to build our tree whenever an instance of our class int tree is made. We also have our print preorder and our print in order. Now we're going to print sideways. So again, we need to pass in the overall root, and then we are also going to pass in our current level, because remember, like I said, it's based off of our level. So every time we do this recursion, we need to change how many spaces we're putting in. You can call this level or you can call this spaces, whatever you want. Let's create a method print sideways. So we have private void print sideways int tree overall root, and then we're gonna call this int, and I'll just say spaces. Remember, the spaces is based on the level, so you can have level or spaces, whichever one works. We're going to want to run this like usual if our root does not equal to null. If it does equal to null, that means we have reached the end of our branch. Remember, if you wanted to print it out like how we have up here, you're going to do the opposite of what I'm doing now. We're going to do it like this. So 7 is up first. We're going to have to go all the way to the right. So we want to go to the right to print out our 7. Coming in here, we're going to say we want to recursively print sideways, and we're recursively going to look to the right. So we need to get our overall root, but we're going to do dot right, and that's going to get us the right of it. And we need to increment our spaces as well. So every time we go down a level, we're going to do space plus 1. So we have our start spaces plus 1. And there's an error because there's a mismatch here. We'll just change this to root because it's not going to be the overall root every time we go through this. Now inside of here, after we print out one of these, we're going to have to deal with our spacing. But we should deal with the spacing actually first. So what we should do is print out 2 spaces and then print out our 7. We still have no problem the way we're doing it right now, because this is going to recursively run until we hit a null value. Once it hits a null value, we still haven't printed anything. Remember, this isn't printing anything. This is just recursively going through this. Now is our time to print. So we are going to, after we've gone to the null, we go back up 1 iteration, we are going to be at the 7, and we need a for loop to print out how many spaces. I'm going to show you everything once the code is printed out, so you'll understand this a lot better if you don't now. We're going to say int a is equal to 0 initially. We're going to want to run a as long as it's less than our spaces, and then we'll have an a++. Now inside of here, we are just going to want to print our spaces. So let's do a system.out.print. We don't want to do print line, otherwise it'll make a new line every time and not just spaces. And we are going to want to just add in a single space in here. And this is going to be our for loop that prints the spaces before the relative root. That's what we're doing here. Now it's time to print the relative root. So how do we print the relative root? Well, all we need to do is print the root. It's that simple. So we'll do an sout.println, because after we print this root, if we look back at what we have here, after we print this root, we are going to want to move to a new line, where we would print like this 3. Because this 7's on one line, although it doesn't look like it, this 3 is on one line, and then the 6 is on a different line. So that's how we're going to do it. Print a new line every single time. We just need to print our root.data, so we get the value at our current root. Now, after this, we are going to make a call to our left subtree. So we've previously looked to the right? We've gone down to the 7. We've checked to see if it's null. Now we need to check to the left to see if there's anything here. So let's go in here, and we're going to print sideways, but we are going to pass in, instead of overall root right, we're going to pass in the left, and then we still have spaces +1. However, there's a huge mistake in here, and it's from our previous header right here when we had this as overall root. Can you see it? Well, we want to be working with this root. This root is going to be relative, and it's going to be changing every time we run through this. If we use overall root.right, it might not give us a correct answer, because this is not changing. So instead of overall root.right, we need to change this to root.right, and this one to root.left. If we run this, we're going to print exactly what we wanted here. Now let me show you how this code works relative to our tree. Bringing this example in here, let's go over it. So the first time this runs, our root is going to equal to 1, and our spaces is going to equal, and I'll just call this s, is equal to 0. The first time we go this, our root does not equal to null, so we're going to print sideways and pass in our root.right. That's going to go to here. Now our spaces is +1 as well, so while our 3 is our root, spaces now equals 1. We recursively go in this again with our root.right. So going into here, root is 7 and our spaces is now 2. We'll go through this again. However, root is now null, so we have to go back up one iteration, doing nothing in our if statement. With our s is equal to 2, we are going to go into the for loop. So we are going to print out 2 spaces with this. We're then going to print out our root.data, which is 7, and then we're going to want to look to the left. So if we look to the left, we're looking this way, it is null, so we're going to want to return our iteration, not doing anything. From there, remember we've already printed out our left and our data, everything is done, this is completely finished, so we're going to want to backtrack back to this node, this 3. And now we're on line 82 for this. Remember after we did that 7, we had a print line, so we're now on a new line. Since this went to the right, we are now at the step where we have to do the for loop. S is equal to 1, so we're only going to want to print 1 space, and then we print our root.data, which is 3. And then we need to look to the left. So we look to the left, we are going to get 6. Spaces is now equal to 2 again, because we have to increment it when we run through this. So spaces is now 2. We need to check for the right with recursion, so we go to the right, it's null, we return. We print out our root.data, which is 6. Remember these spaces is 2, so there's 2 spaces, 6. Now we check to the left, null, so we just return here, and then we're going to want to return back to this 3. Now we've already printed to the left, so we finish this recursive part, and we can return back here. And then we're going to basically do the same for the other side. Let me show you this in our debug menu. So with this understood, hopefully, if not, watch it again. I'm going to scroll up, and I've made a test case right here. I made an instance of our tree, and I say x.print sideways. This is our call here. Let's run the debug of it, and you can see in the console on this side what it's going to come out. You can see in our debug menu what is happening. So once we build our tree, I'm going to step into our print sideways. It's going to go into the public method, then it's going to go to the private method. Our root does not equal to null, so we're going to keep running this, and then I'll keep pressing this, and you can see that it's going to continuously go through the iterations here, printing out our 7, printing out the 3, printing out the 6, printing out the 1, and then it'll keep going. It'll print out the 5. So now it's false at the bottom of 5. Remember 5 was at the end right here. It's going to check for another value. The root is now null, so it's going to return to the previous iteration. And so it just keeps going down. We have 5, we have 2, and eventually we'll get 4, and then we have a null value here. Then we're going to go all the way up to the top, and then that is going to be it completed, and we would return this. That is going to be another method in our int tree class. If you want more methods, check out that playlist link below the like button if you want to see more tree videos. Also check it out, and if you have any questions, leave a comment below. We're going to be going over adding next. That'll be very fun.